Stand here. Can wave at me to say stop.
Yeah.
I think we're good.
We can call the first speaker.
Because, yeah.
So, good morning. Welcome to this session. Again, we'll have a very brief introduction of the research that's happening in terms of applications of natural language processes. My name is Mapundi Banda. I'm in the Department of Mathematics and Applied Mathematics. Probably you're wondering why. So I call myself a natural language mathematician. You probably saw my name on the presentation that Abebe made. So what we do is to go inside the kernel of these processes to understand the mathematical underpinnings of what you guys are doing research on. So in terms of being lost, I'm also very lost. But I hope sooner or later I'll find myself in terms of low resource languages. That's where we're working. So the first speaker is Nontokozo. I'll call Nontokozo to come and present to us. Thank you very much.
Able to use the clicker.
Yeah.
Yeah.
Okay, thank you.
You can take it. Yeah, don't touch. That's another microphone.
Okay,
Yeah.
thank
Yeah.
you. Good day, everyone. I am Nontokozo, and I am currently doing my master's, and I'm supervised by Prof. Marivate and Mr. Joseph Sofara. Okay, so my research is about interpreting isiZulu idiomatic expressions with large language models. Okay, so this problem statement is adapted from previous literature and some interactions I've been having with some of the large language models. Well, current large language models are failing to interpret idiomatic expressions, especially in low resource languages like isiZulu. Okay, so let me make just a simple example. When you take a simple phrase like Isandla sigeza and then you tell some of the LLMs to help you interpret it, they are most definitely going to give you an answer that say hands washes each other, which is technically correct, but culturally it's very empty and very hollow. It actually means something that is much more profound than that. It means that we survive together, no one succeed alone, and it emphasizes the spirit of Ubuntu. Okay, so I'm sure you're wondering why these LLMs are failing when it comes to interpreting idiomatic expressions, which are figurative language. It's because these expressions, they are underrepresented in training data, and also they are non-compositional, non-literal, which means that you cannot interpret them word for word. So they need to be very context dependent, and they are cultural rooted because most of them are taken from our history, our values, and community. Okay, so which leads to the LLMs, which are our large language models, to guess, hallucinate, and misinterpret, which misses the whole definition of the idiom. So this is bad because isiZulu is one of the languages which consist of 24% are native speakers, which is roughly 12 million. So, and we have zero dedicated NLP system for isiZulu idioms, which means that Africa is still underrepresented in AI. Okay, so moving to our approach. So basically here what we have is we have a three-way method which helps us to comparatively analyze which method between the three helps the LLMs to better interpret idiomatic expressions. Okay, so we have a RAG, which is retrieval augmented generation. We have fine tuning. We have a baseline. Okay, what is happening here? I'm sure you're wondering. Okay, firstly, we collected data sets, we collected two data sets, one for fine tuning and then one for RAG. The one for RAG is just simple to help the LLMs reason better when it comes to idiomatic expressions. And then the other one for fine tuning was divided into three sections, whereby we first did hyperparameter tuning, just to get the best parameters we can use to fine tune the models. And then after fine tuning, we get the output and we evaluate it against the three conditions just to see which method has the potential to make the LLMs to better interpret idiomatic expressions that are in isiZulu. Okay, so here are the preliminary results for the baseline models with no RAG and a fine-tuned models. The other one with RAG is still a work in progress. So right now we currently have this one. So we fine-tuned 4 models, which is Llama, a model from Meta, Gamma, a model from Google, and GPTOSS, which is a model from OpenAI. Afro-Llama is just an Afrocentric variant of Llama. So as you can see here, if you compare the models from the baseline, which is the side, to the values from the fine-tuned, they increase, meaning that that suggests that fine-tuning has the potential to help these LLMs to be able to interpret idiomatic expressions. Okay, so in conclusion, what we have accomplished so far, we have managed to build a data set, and also we have managed to build a pipeline for fine-tuning and RAG. However, we're still evaluating RAG. And also the road ahead now is just to evaluate all these 3 methods against automatic metrics and also human evaluation with the help of linguists, of course, and also writing up and submitting. Thank you.
Thank you very much. Any quick comment? Okay, thank you very much. You can take a seat. Okay, so it's a name. It's a no-name brand. Okay, so you introduce yourself since you didn't put a name on the slides.
On the next slide.
Okay. All right. Let's go.
Okay, afternoon. My name is Miehleketo, and currently a PhD candidate at the University of Pretoria under Dr. Abi and Prof. Gosi. The research focus is on NLP for ESG analytics, ESG indicator extraction from financial reports, and as well as AI system for ESG-oriented financial intelligence. The problem statement, mostly with the ESG data, it's predominantly unstructured and it's narrative driven. So it's basically available in PDFs, disclosures, reports that are not consistent, and they basically lack standardization. So when you're dealing with them, you have to deal with one in different format, as well as how they basically report 1 month, 1 financial year, it's one format, and then the next financial is a different format, which is basically difficult to analyze and basically do comparison when you go, which as well as it limits with the AI-driven analysis and with the financial intelligence of ESG. The research gap currently, so we've got limited integration of ESG data, AI models and financial intelligence within the South African context. We have currently lack of standardized machine-readable ESG data sets, only basically focusing on the South African context. With the current AI-driven ESG system shows limited integration of governance frameworks. So we've got a king for the JSC sustainability, the GRI, the TSFT. So those are kind of the governance frameworks that the companies follow when they report the ESG, as well as the development agenda. So we know that we have the UN Agenda 2030, the National Development Plan, South African National Development for 2030 as well, and the African Union Agenda for 2063. So with the research objectives, so firstly, it's just to create the South African financial intelligence ESG dataset. So this is a unified dataset that it's mission readable, and as well as just to create the data infrastructure that can be reused by other researchers as well. Develop AI models, knowledge graph systems that basically automatically extract, integrate, and analyze ESG information from different reports. Develop the ESG-oriented financial intelligence application that supports the real decision-making for investors and policymakers, such as just to do greenwashing detection, anomaly detection, ESG scoring, and SDG alignment, just to make sure that we are tracking the SDG element for the UN Agenda 2030. Key findings currently with the systematic literature review that we've done. So we basically can see that the AI research is dominated by the Asia and Europe, because those are developed. They've got infrastructure, better data infrastructures that helps them to basically carry on the research in related to AI and ESG. With Africa, we have a very limited representation. Mostly the papers that are there don't really speak of the data. The data is not publicly available, which highlights a gap in ESG research for South Africa. The pipeline, so far, we've collected from 50 South African organizations. So it's 40 JSC listed and 10 SOEs, which include ESCOM and the likes of SA Airways. The reports span from 2015 to 2025 financial years. So we've got corporate ESG reports, the corporate disclosures, financial statement, integrated reports, governance and policy frameworks, ESG news, related article news. So the data is collected using a web scripting that we've developed and document for pipeline extraction to basically preserve the contextual and regulatory authenticity of the South African ESG disclosure. Like I've stated, that is basically limited to the South African context. So we only collecting the South African organizations' research impact. So to support data-driven ESG decision-making for investors and policymakers, to improve ESG transparency, enable greenwashing detections and ESG risk analysis, and align with the SDGs 13, which is climate change, 9, 11, and 16, which touches on other like for governance, peace, and justice, and infrastructure as the SDG 9. In conclusion, to develop an AI system for financial intelligence in South Africa, transform unstructured ESG disclosures into decision-ready intelligence, and integrate data, AI models, policy into a unified system. The takeaway is from fragmented ESG report to scalable AI-driven financial intelligence, enabling sustainable and accountable economies. Thank you.
Thank you. Quick comment while we're setting up. Yes, there's a hand at the back there. Saika.
Yeah, just take the mic and repeat the question, just for people to know.
Okay. Can you just repeat that so we can hear it?
Stand up and give it back to you. Have you reached out to maybe Saika
There's been some ESG-related requests for very similar things coming to CSIR, and they could be a good source of data basically from the horse's mouth, and they could help you on the front of standardization, because if they are putting out kind of statements to their members to say, this is how we expect you to standardize your reports, that could help you get better structured data.
Okay, cool. Thanks. We'll note that and try to reach to them and work on that. Thanks.
Oh, thank you very much. Let's give the speaker another applause. So next speaker, Dinorego, is behind me, and I'll hand it over to you. Thank you.
Okay, thank you. Good morning, everyone. My name is Dinorego. I'm also a PhD student under Professor Marivate and Dr. Modube. So today I'm going to tell you my PhD research idea, which is on multilingual air traffic control aware collision avoidance system. So this is a build-up of a master's degree on automated control systems. Okay, so what is the problem? So our problem originates from automating aircrafts and the fact that they cannot safely understand multilingual air traffic control instructions currently. So the current collision avoidance systems are vision only or controlled by a radar data set. So meaning they cannot process natural language data set originating from air traffic control. So even though some language capabilities do exist, they are currently limited to English data set now. So what do we want to do? So we want to include African languages such as isiZulu, Swahili, and Xhosa, and Yoruba, and so on. So we'll incorporate more once the framework start working with the data set that we have. So what's our focus? So we'll be focusing on what we call foundational multimodal models, which offer solution integrating speech, text, and visual understanding. And we are aware that this kind of models have what we call issues with hallucination. So we cannot quantify their uncertainty, lack of safety guarantees as well. And we know that aviation is a high-stake environment. So we need to come up with engineering methodology to make sure that whatever we generate or recommend from the systems, we're able to guarantee their safety. Okay, so why is this matter? So we're concerned with safety risk, equity gap that exists as well, and some regulatory barrier looking at the application area. Okay, so our research approach will be going in this manner. So currently, the approach is to fine-tune any of the existing models for African aviation context, then validated through verifiable safety mechanisms. So that is where the contribution will lie in terms of engineering the systems. So several steps. So we'll do this in several steps. So step one will be to leverage any of the existing foundational models, right? So there's a lot that has been done in this knowledge that exists with this foundational model. What we want to do is that we want to contextualize for the problem that we want to solve and then take it from there. So I'm listing some of these models that I recently come across. Gemini Embedding 2, which is a natively multimodal and is able to process speech, text, and so on. So we want to make use of this multimodal language embedding to be able to understand the speech data set that I have already come across from other researchers as well. Also, another one to mention is Tiny Aya, which recently came out as well, which is an open weight multilingual model covering 70 plus African languages. And within those, what is included is the language that we're interested in, right? So Okay, but also the benefit is that we can run these models locally. So it means we don't have to rely on the cloud platforms to be able to run these models, right? So some of the systems perhaps will be in an area where there's no access to internet. We want to be able to utilize these LLM technologies. Okay, so step number 2 is about considering safety and the validation layer. So we need to think about the safety of the systems that we embed in part of our aviation ecosystem. So there will be considering Bayesian reinforcement learning, which quantifies uncertainty, symbolic safety guardrails that we need to encode as part of the regulation, fine-tuned multimodal output that we need to verify. Okay, sorry, there's another step number 3, which is about explainability and trust of issues, but I'm running out of time. So let me perhaps maybe talk about the architecture. So that's the overview of the pipeline or the architecture that we're going to implement. So I'm not going to delve a lot on this. Perhaps maybe allow me to skip and tell you about the pipeline. Is that we have a pipeline divided into 6 stages where we'll need to consider the input in terms of multilingual air traffic control speech data set. Then we need to do automated speech recognition processing. This is to transcribe the speech using fine-tuned models, and also design what we call a reg retrieval system. So with this, we're going to take existing documentation from different aviation regulatory bodies, and make use of those to be able to contextualize our generated outputs. Okay, so then we have number 5, your safety validation and the execution and explainability as well. So those are the things that we need to be focusing on. So some of the relevant data set that we have are listed there, and some of the models are on the right as well. I've already spoken about this. So perhaps maybe let me talk about work done so far. I've done 3 studies. The first one was on the benchmarking of the existing models, considering the MIT data set. So number 2 is on a developed physics constraint generative models to verify output made by these models. Okay, so conclusion is that we want to promote inclusivity and safety. So these are the models that we are going to implement. Thank you.
Thank you very much. Quick comments? Yes, there's one.
Apart from the benchmark, what form of validation and evaluation are you planning to implement to verify the usability of your?
Okay. And repeat the question and answer.
So you're talking about mechanisms to verify, to evaluate the output of our work, right? So the REC system will take in documents from the systems that are already in the aviation industry, making sure that what our model generates in terms of decision making follow the safety and regulations already approved by different regulatory bodies. So whatever we generate, we'll be making use of the REG framework to make sure that the model do not hallucinate, but whatever is recommended, it's what is already regulated in the industry. I don't know if that answers the question. Okay, I'll follow up with you on it. Thank you.
Yes. So there's a discussion for lunch there. Let's thank the speaker again. Okay, the next speaker is Thapelo. Thapelo, come to the floor. Thanks.
Thank you so much, Prof. My name is Thapelo Sindane, and I'm a PhD student at the University of Pretoria as well, under the Data Science for Social Impact Research Lab. I don't know how to go back then. Okay, there you go. In terms of supervisors, just a disclaimer, I've been supervising myself the entire time. So I'm just throwing it out there. So my entire journey has been self-supervising. I don't know if that's a word, but I've been supervising myself. Yeah, I'm just joking. supervised by Prof. Kosi, Dr. Biodon Mudupe, and Hercules Kombrink. By the way, there's Hercules' student over there. A pleasure to meet you. So I'm going to talk about Dipolelo, an automatically collected, prepared, and benchmarked dataset for the South African Sign Language. So Dipolelo is the name of the dataset that we try to collect. So essentially, we're trying to create a framework for showcasing that we can automatically create datasets with very limited human intervention. So to give context, there's about 12 million people in South Africa that are suffering from some form of hearing loss. This could be starting from mild to severe, and about those, only 600,000 of them use South African Sign Language. And then the issues that causes this number to drop to that number is that there's a barrier such as shortage of specialized schools and learning opportunities in South Africa. So for you to find education or schools in South Africa that teach sign language specifically, you're going to have to travel to remote areas like Sandton, Rosebank, and things like that. So for people that are in our rural areas, don't really get access to these things. And to make matters worse is that deaf people really struggle to communicate with hearing people. So most of us in here, I can assume, and I think I would be assuming correctly, that we don't know how to speak sign language. So that really perpetuates the issue in this context. So what can you do to maybe alleviate this issue? We started by trying to figure out how can we develop data set that can facilitate some intermediate model to translate between spoken language and sign language and do it in reverse. So by trying to remedy this, we could improve communication between the deaf communities, which would promote essentially social inclusion and equal opportunities and access to education amongst other opportunities that they might get. This image right there contextualizes the work that we're trying to propose because we essentially targeted the South African Broadcasting Corporate Commission, the SABC, to collect data sets. So what is our research? Our research is to try and create a framework that exemplifies how to automatically collect a data set for the South African Sign Language, utilizing the SABC as the targeted source of our data set, using motion-driven techniques and other techniques that we'll talk about in this space to create a parallel corpora between spoken language, which is what you see here on the left, and then the sign language, which is what you see there on the right. I'm skipping a lot of things in the interest of time. So here's the general pipeline in the general sense. So we start by crawling data from the SABC, so a YouTube video that has an interpreter section, and then we use some ASR model to transcribe spoken language into text, and then do some sentence tokenization, because it's easy now because we're working with text data. And then through that information, where we've tokenized the sentences that are in the large audio file, we know how many sentences we expect that corpora to have. Then we use that information to crop the video that will be downloaded as well. And then use some motion-based video segmentation to break down the video into small chunks that represent sentences. How do we do that? We track the locations of where this speaker in the video is stopping or pausing, so that we can segment based on those things. We use gradient descent to actually do that, to detect the plateaus. The gradient helps us to detect that plateau where we can segment the video. And then from that, we use stratified sampling to make sure that when you are training your model, the distribution of the data sets in the train are actually similar to what is in the dev and also what is in the test. In terms of key results, we started by doing ablation studies to figure out if we are training with a specific batch size, how does that impact the learning rate, and doing it vice versa. We found out that specifically looking at the blue 4 score, which is the prominently reported metric in the space of sign language translation, a batch size of 32 and a learning rate of 1 e to the power of 4, meaning it's 0.00001, actually performs better. And then we benchmarked our data set, which is, remember again, it's text that is aligned with sign language. Through a couple of models, we were able to see that basically transformer-based models tend to do better compared to this is a deep learning model that uses recurrent neural networks like your GRU, LSTMs, we've tested those. But models that use transformer-based architectures tend to do better. This is just a model that we've trained longer. It's a transformer model that is actually trained longer. There's nothing remotely interesting about it. So in terms of the future or the last mile or what we intend to generate as an artifact of this, we wanted to create a platform where this is basically practical, where you can upload a video and then it will generate an equivalent sentence based on that, because we actually started with sign language translation, not sign language production. Let's see, GT stands for ground truth. So if the ground truth example is, and it was incumbent upon us to set up policies, our models currently were able to generate, given a specific video, remember, this is, but we do that, we had the policies which we had to set up regarding the language. So we can see that key features are identified. Policy setting up is being flagged. So with more data set, essentially, we are able to get good results. I'm going to jump to call to action. So this work requires a multidisciplinary approach because we need deaf communities, interpreters, and government to be able to work together in these aspects. So please reach out to me, then I can expand on other things that we talked about. Yeah.
No, thanks a lot, Thapelo. There's a quick question there. Don't run. Motivation.
You mentioned text, data set, and video data sets. I don't know which of them.
Yeah.
It's going to give you what's going to differentiate a normal gesture from a sign language.
Yeah.
Because you were presenting, you were making gestures.
Okay.
The motivation.
Yeah, the motivation, firstly, is that I have got a kid who's deaf. Yeah, my daughter is actually deaf, goes to a school called St. Vincent School for the Deaf in Rosebank. That's why I found this work quite interesting to do. Touching on the second question, what's interesting about sign language is that some gestures that are similar to what people would recognize as conventional gestures are actually sign language. Like, for example, for food, you would say something like this. They are all under the umbrella of something called iconicity. So where a sign language is equivalent to something that appears natural to you, right? Yeah. So sometimes those gestures that I'll be making there are actual sign language. Like crying would be something like this. So you're making a gesture that is somewhat natural to crying. I don't know if I'm answering your question, but yeah. But it goes deeper than that because it's a fully fledged language.
Lunch. You guys can talk over lunch. Thank you very much, Thapelo. An applause for him again. So, again, give yourselves an applause. Thank you very much for all the interesting comments and questions that you've been asking. So you can give yourselves an applause as well. Thank you.
Okay, before that, I just want to connect to another, I think, is it 2 AI4D labs that might be working, or also expanded community? So I think we got the comments from Sadela about the dev community. I think it's a great lunchtime, Thapelo, I think engage. We are working also on connecting. There's the AI4D responsible AI lab in Ghana, and they're also working on Ghanaian sign language, and we're hoping to do some work with them. And there's also a team, Lilian Wanzare, in Kenya, and they're doing also Kenyan sign language in this area. It's like those things again of finding that there's all these teams at around the same time working on these things. Is now how do we bring them kind of all together to really combine what they're doing in these spaces. So it's a very interesting kind of period before this. Yeah, sorry, I just need to make sure it's shared on Zoom. Okay. Okay, the next speaker is Prof. Heinfenter. I think he'll have 18 minutes to speak, and then hopefully a long 7-minute Q&A session.